Welcome back, Professor Bright here, and our next topic of study is actually going to look at trig functions of any angle. So before we've talked about trig functions maybe on the unit circle and in triangles. Now we're just going to consider a general angle. So it's maybe not, it could be acute, it could be obtuse, and we don't know if it's necessarily even on the unit circle. So again, we're thinking still in standard position though, just to make our lives a little easier. So initial side along the positive x, and then I'm going to draw my angle just so it has a terminal side in quadrant 3 just for fun. Okay, we're going to call that theta. Okay, and so we're wondering, if this side passes through a point that has coordinates p of x, y, okay, how do our understanding of trig functions change? Okay, well, what we're going to see is that if we imagine extending an altitude from this point to the x-axis, okay, that side length would be y, and maybe technically because we're in the third quadrant, it would be a negative y value. We're just going to do the absolute value of it. In the same way, this side, again, if we're thinking about a triangle, it would have side length or absolute value of x. But since we are embedded in the Cartesian coordinate system, we're just going to use x and y, okay? But with this idea in mind, this looks remarkably similar to our trigonometric function definitions in the context of a triangle, right? We have two sides of a triangle, right triangle that is. We make a right angle there. And so then we would talk normally about this angle in here. Okay, I'm going to use a symbol, theta prime. We'll talk about that in later videos, but theta prime would be our angle that we would be working with. It ends up actually being nicely related to theta, but we have an acute angle, we have two side lengths, and then our hypotenuse we could find, we're going to call that r for now, and we could find it using the Pythagorean theorem to be x squared plus y squared, square root of all that, okay? So all we need to do then is adapt our notation, our understanding of trig functions to kind of those of triangles. And so even if we're not on the unit circle, we can still talk about the trigonometric functions. And so here we are. We can now say that sine of theta in this context would be, here's our acute angle, theta prime. We'll talk about why I put a prime there later on. But in this case, if we look at the triangle, the value of sine would be the opposite over hypotenuse, so y over r. Cosecant would be its reciprocal. Cosine would be adjacent x over hypotenuse r. Secant is the reciprocal. Tangent would be still opposite y over adjacent x. And reverse that for cotangent, okay? Now keep in mind, I mentioned to kind of develop this, I use the idea of triangles, right? So typically when we work with triangles, we're working with all the side lengths. However, we are embedded in the Cartesian coordinate system, and so that comes with it signs based on the quadrant. So if you remember that acronym or that mnemonic ASTC for all students, hopefully, take calculus, we remember that means that in quadrant 1, all trig functions are positive. Quadrant 2, sine and its reciprocal are positive. Quadrant 3, tangent and its reciprocal are positive. And in quadrant 4, cosine and its reciprocal are positive. Okay, so just remember to include the negative. Okay, so here we go. We have an example. All right, so we have a point P located at, positive 3. So we're going to say this is positive 3. Down at negative 7. So we have our point there. And so it's on the terminal side of theta in standard position. Okay, so here's our point, 3 minus 7. Okay, find the values of the 6 trigonometric functions of theta. Okay, so for this, remember that this is x, this is y. Then according to the definitions, right, well, okay, let me pause before I go further. I can no longer say that, sine of theta is equal to 3. Okay, we talked about the domain and range of sine, or sorry, this would be -7 rather. We talked about the domain and range of sine, right? The domain or the range for sine, what it outputs is between -1 and 1. So if you write something like this, that is way wrong, right? So what we need to do is we need to scale this according to our definitions, okay? So we need to find whatever this r value is. Okay, so let's do that off to the side, or maybe down below. So we need to find r. It is the square root of x squared plus y squared, square root. So square root of 3 squared plus -7 squared, end up getting square root of 58. Not a nice number, but hey, we can work with it. Okay, so sine would be y, -7, over square root of 58. Cosecant would be its reciprocal, square root of 58 over -7. Cosine is x, so +3 over r, square root of 58. And then secant would be its reciprocal, square root of 58 over 3. And then tangent is y, -7 over x, which is 3. Cotangent is its reciprocal, 3 over -7. All right, and that would be our answers there. Okay, so again, key thing, you can plot your point, right? And chances are if the coordinates are bigger than 1, you're probably not in the unit circle. So remember that you need to find this r value and incorporate that into your definitions. Okay? Again, all of this is extending from our understanding of triangle or trigonometry in the context of triangles. Okay? So now this last exercise, I'd like you to pause the video, try it out, and resume when you're ready. And here's a solution. So again, I started with a diagram here off to the left. You can see I plotted theta, I plotted the point, and then I kind of made that triangle just so I could see it. And again, there's this theta prime symbol, which we haven't talked about yet. You'll see it in videos that are following this. Okay, but nevertheless, so I know y, I know x, and I know y, and I needed to find r for my definitions. So I found that by square root of x squared plus y squared. Positive square root of 29, and then I carried that through in my definitions. Okay, just remembering sine is y over r, x over r, y over x. All right, so there we go. We have now another definition of trigonometric functions using any angle, even if the angle corresponds to a point that is not on the unit circle.